Hello friends, welcome to Dr. Acharya Academy. Today we'll discuss about the chemistry for class 11 syllabus CBSE, and the topic is the laws of chemical combinations. If you not subscribed till now, please subscribe the Dr. Acharya Academy to continue with this class. Today's class number 006 CBSECH11-006. For the numbering system, I want to tell something. I started the class with both class 11 book number part 1 and part 2, and simultaneously also for class 12 chemistry part 1 and part 2. So for numbering, whatever I have done, that if it is class 11 chemistry, then it is CBSE CH for the chemistry, and 11 means class 11. And when it started with the part 1 book from the NCERT, then its class number started from 001. So from 001 to 005 I already covered. Now it is the 006. But when I'll start with the class 11 book number part 2 and then unit number 1, then it will start with the class number same CBSE CH for chemistry. 11 means class 11, but here numbering will start with the 201 and it will continue. And it is, if it is for the class 12 book number part 1, then the class will start with the CBSE, this numbering system, CH for chemistry. Class 12 means here 12 will come, and then it is the part 1. If it is part 1 book number, then it will start with the 301. I already started with this numbering system for the class 12 part 1 class. And if it is the class 12 and book is part 2, then the numbering system will start with the CBSE CH class 12, and if it is part 2, then it will start with the 401. I already uploaded some class with this numbering system. So if you want to find the class 11 chemistry for the part 1, then numbering system 001, 002, you have to follow in this way. And if the chemistry class 11, you start with the part 2 book, then the numbering system will start from this. And if it is class 12, book number part 1, then it will start with the CBSE CH12 301. And if it is class 12 chemistry with the part 2 books, then it will start with the CBSE CH12-401 and it will be in chronological order. So I think that now you understood clearly what is the numbering system for the class. Now I'll start today laws of chemical combination. It has 5 laws, basic laws, and number 1 is the law of conservation of mass. Second, law of definite proportion. Third law, law of multiple proportion. then Gay-Lussac's law of gaseous volumes, and last the Avogadro's law. So today these 5 laws is our learning points. We'll start one by one. So first, law of conservation of mass. In the year 1789, Lavoisier performed experiment for the conversion reactions and reached the conclusion that all physical and chemical changes, there is no net change in mass during the process. So he reached to the conclusion that matter can neither be created nor be destroyed. So the law of conservation of mass, all physical and chemical changes, there is no net change in mass during the process. Matter can neither be created nor destroyed. This is called the law of conservation of mass. This law is the result of the exact measurement of the masses of the reactant and products, which is carefully performed by scientist Lavoisier. Now we'll go for law of definite proportions. We'll see some history. This law is created by the French chemist Joseph Proust. What he stated? He stated that a given compound always contains exactly the same proportion of the elements by weight. He worked with 2 samples of cupric carbonates, either it is natural or synthetic. In both cases, his findings is for the natural cupric carbonate samples, copper is the 51.35%, carbon is the 9.7%, and oxygen is the 38.91%. And for the same compound, when it is synthetic, same proportion in respect of percentage for copper, carbon, and oxygen. So with this, he concluded that irrespective of source, in this case whether it is natural or synthetic, a given compound always contains same elements combined together in the same proportion by mass. That means same elements for the cupric carbonate, copper, carbon, and oxygen, and same proportion, either it is natural or synthetic, whatever source is there for this particular compound. So the law of definite proportion is irrespective of the source, a given compound always contains same elements combined together in the same proportion by mass. This is the law of definite proportions. The validity of this law has been confirmed by various other experiments also. Now we'll come to the law of multiple proportions. This law is proposed by the Dalton in the year 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other elements are in ratio of a small whole numbers. We'll give one example to find this proportion very clearly. The example here, if you see the hydrogen 2 gram react with the oxygen weight 16 gram will produce the 18 gram of water. And with same element produce the another compound. Example is the hydrogen peroxide. First case is the water, second case is the hydrogen peroxide. So 2 grams of hydrogen in case of hydrogen peroxide, react with the 32 grams of oxygen to produce 34 grams of hydrogen peroxide. So here you can see that in both cases, hydrogen 2 grams of hydrogen react with different amount of oxygen to produce the product. So in each case, for the water, 2 grams of hydrogen react with the 16 grams of oxygen, and for hydrogen peroxide, 2 grams of hydrogen react with the 32 grams of oxygen. So for the same amount of hydrogen, the reaction of oxygen to get different product, water and hydrogen peroxide, is 16 grams and 32 grams. So ratio of these amounts of oxygen with fixed amount of the hydrogen gas is the 16 ratio to 32 or 1 ratio to 2. That means ratio 1 and 2. So this is the simple ratio of the whole numbers. Now, Gay-Lussac's law of gaseous volumes. This law is given by the Gay-Lussac in the year 1808. He observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. When we usually consider the volume, we always will put the temperature and pressure same for all gases. So example, hydrogen, that means 100 ml of hydrogen react with the 50 ml of oxygen to produce 100 ml of water vapor. So here if you see that 100 ml of hydrogen combined with the 50 ml of oxygen to give 100 ml of vapor, water vapor. Thus, the volumes of hydrogen and oxygen, here 100 ml and 50 ml respectively, they combine and bear a simple ratio 2 to 1. That means 100 proportional to 50, that means 2 to 1. And Gay-Lussac's discovery of integer ratio in volume relationship is actually the law of definite proportion by volume. Previously discussed about the law of definite proportion by mass. Here you can see by volume. And in this case, always all gaseous gas is under the same temperature and pressure. That always you have to remember and you have to write. So what is the Gay-Lussac's law of gaseous volumes? When gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. These we have to mention always during the description of the Gay-Lussac's law of gaseous volumes. Now, Avogadro's law. In the year 1811, Avogadro proposed that equal volumes of all gases at the same temperature and pressure. You see that always you are mentioning that at the same temperature and pressure when you are describing the volume of the gas. It should contain equal volumes of molecules. Same example, hydrogen 100 ml, oxygen 50 ml to produce the 100 ml of water. If we consider that the reaction of hydrogen and oxygen to produce water, we state that 2 volumes of hydrogen. That means if it is 50 ml, 50 ml, 2 volumes, then react with the 50 ml oxygen, that means 1 volume of oxygen to give 2 volumes of water. That means 50 ml and 50 ml, 2 volumes. That means if you consider this 2, then it will be 1 and it will be the 2 volumes. And without leaving any unreacted oxygen. That means whole oxygen is consumed during the reaction. So Avogadro also made a distinction between atoms and molecules, which is quietly understandable nowadays. Now, if you consider the same reaction, then we'll find by the figure to understand clearly. Here you can see that 1 volume of hydrogen and 1 volume of hydrogen, that means 2 volume of hydrogen react with 1 volume of oxygen to get the 2 volumes of water vapor. So for each box, if you see the molecule, because Avogadro proposed the concept of molecules. Molecules differs from the atom. So 1, 2, 3, 4, 5. That means same volume has same number of molecules. So it is 1 volume, it has the 5 number of molecules, and in this case 1 volume, it also has 1, 2, 3, 4, 5 numbers of molecules. And it reacts with this volume, and this volume is same. So it also should have the oxygen molecule, same number 5, 1, 2, 3, 4, 5. And these will react to produce the 2 volumes of water vapor. 2 volumes means every 1 volume contains the 5 number of molecules, so it should be the 10 number of molecules. We'll find that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from this figure, it is clearly understood that same volume has same number of molecules. And here the concept is the molecules to be considered as polyatomic, which is later considered as the molecule. So now the Avogadro, what is the Avogadro's law? Equal volumes of all gases at the same temperature and pressure. Always you have to mention this, otherwise this law will not be complete. Should contain equal number of molecules.